Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. So we've talked about the structure of a model, this idea of a neural network with layers that process information. But that leads to the crucial question of when a model learns from data, what is the specific tangible thing that's being changed and stored? If the neural network is the anatomy, what represents the physiology, the learned knowledge itself? The answer is a concept called parameters, and understanding them is key to understanding both the power and the pitfalls of AI tools we're starting to see in today's practice. The simplest way to think about a parameter is a single adjustable dial inside the model. The model doesn't have one dial though, it has millions, sometimes billions of them, and these are internal variables the machine can tweak. The knowledge of an AI model is the final setting of all of these millions of dials. A good clinical analogy is titrating a medicine. So when we start a patient on warfarin, we have a goal, get the INR in this therapeutic range, and the dose that we give is the parameter. We check the INR, that's the feedback signal from the data. If it's too low, then we nudge the dose up. If it's too high, we nudge the dose down. And we repeat this until we find the stable dose that works for the patient. The training process for an AI model is exactly this, but on a much bigger, massive scale. When we feed it a chest x-ray labelled pneumonia, the model makes a prediction. If it gets it wrong, the algorithm gives it feedback and the model makes millions of tiny adjustments to its internal parameters, the dials that it can tweak, to be more accurate next time. After seeing hundreds of thousands of x-rays, the final configuration of all of these millions of optimized dials is the model. It's the saved set of numbers that represents everything that it's learned. So what's the takeaway from knowing this? First, it helps us understand what training and retraining a model actually means. When a model's performance starts to drift, we don't start from scratch. We take the existing parameters and fine-tune them with new, up-to-date patient data. It's like doing a warfarin dose check for a patient 6 months down the line to see if anything has changed and needs adjustments in the dose or those internal parameters in the model. Third, it highlights a major risk, something called overfitting, which we'll come to in more detail in a later episode. But essentially, with millions of parameters, a model can become so finely tuned to its training data that it effectively memorizes it, noise and all. And this makes it perform brilliantly on the data it's already seen, but it can then fail badly when it meets a patient from a new demographic because it learned statistical quirks, not robust, generalizable clinical principles. So that's parameters in a nutshell, not abstract concepts, but the millions of tiny adjustable dials that hold all of the model's learned knowledge, the things that are tweaked during the training process. If you found this useful, please hit subscribe or follow in your podcast app so you don't miss future episodes.